Hello everybody, so in this video we're going to look at loci involving hyperbola and ellipses. So we can see in this diagram in front of us we have two curves. The green curve is for hyperbola, and we're going to talk about how the orange curve is formed. So the orange curve is formed by a tangent that moves along the hyperbola. And we're going to look particularly at the line segment M to N. And these are points that lie along the tangent. And this red dot is the midpoint of MN. And as we move the tangent along the hyperbola, you can see the red dot follows the orange curve. As we go over here, we approach the origin, and as we go for positive large values of x and y on our tangent, again we approach the origin from the other side. And this will also be true for the negative values of x on the hyperbola. So you can see the red dot again approaches the origin, and if we go the other way, so positive y, it approaches the origin from the other side. So this orange curve then is the locus of the midpoint of MN. And what we're going to do in this video is we're going to find the equation of this locus. Okay, so presented as a question, we're told that the hyperbola has the general Cartesian equation, and the line L1 has parametric equations for the x as a sec t and for the y as b tan t. And the general equation for the tangent is given here. And like you could see, the L1 cuts the x-axis at M and the y-axis at N. And we're going to show that this is the equation of a locus of a midpoint of MN. So the first thing we need to do is we need to find the general coordinates of the midpoint. And you can see that at this point of M, y is always 0, and at n, x is always 0. So we'll start then by saying at n, y equals 0, and when we substitute 0 into here, ay tan t will go. So we're left with ab will equal bx sec t, and we can make x the subject of this by dividing both sides by b sec t. When we do this, this b and this b will cancel. So x will equal a over sec t. So the general coordinate along the x-axis will be a over sec t 0. And we can do the same thing at point n. At n, x equals 0. So now we can put 0 into here, b sec t will become 0, so we have ab will equal negative ay tan t. We can make y the subject by dividing both sides by negative a tan t, and this a will cancel with this a, so we'll have y is equal to b over, or negative b over tan t. So the general coordinate for n then will be 0, and then b over negative tan t. Now if we go back to our diagram, we have m and we have n. We can now work out the midpoint. If we just make this a bit bigger, you'll see it more clearly. So we can work out the coordinate of a midpoint by halving our x value and halving our y value. So if we halve our x value, then we'll have a over 2 sec t. And if we did the same to our y value, we'll have b over negative 2 tan t. So the general coordinate of a midpoint will be a over 2 sec t for our x, and b over negative 2 tan t for our y. Okay, so at this point, we need a way of connecting the sec and the tan, or the x and the y. And we know that sec squared t will equal 1 plus tan squared t. And because we've got a negative here, what we're going to do is move this tan squared t to the left-hand side, and we'll be left with this equaling 1. So therefore, sec squared t minus tan squared t will equal 1. So going back to our midpoint, we know that x is a over 2 sec t. So we can make sec t the subject. So we'll get sec t will equal a over 2x. Similarly, for the tan, we know y is equal to b over negative 2 tan t. So tan t will be equal to negative b over 2y. I'll just move this negative to the top to make it easier for me to work with. So if we have sec t, we can square this to get this term. So sec squared t will be a squared over, and when we square the 2x, we get 4x squared. And if we square the tan squared to get this term, we get 10 squared t will equal, this negative b will become positive b squared over 4y squared. Now all we need to do is substitute this expression for sec squared t and this expression for tan squared t into here. So we get a squared over 4x squared minus tan squared b squared over 4y squared, and that will equal 1. So this is the equation of our locus. Okay, let's move on to example 2, where we're going to look at a similar example, this time using an ellipse. Okay, so in example 2, we have an ellipse, which is in green, and we have the locus, which is in orange. And we have a normal to the ellipse, which is this line moving here. And you can see that on the normal, we have points M and N, which lie along the x-axis and the y-axis. And as we move the normal around the ellipse, you can see the midpoint of that line segment MN follows the orange curve. So the orange curve is the locus of the midpoint of MN. And what we're going to do in this example is we're going to find the equation of this locus, okay? So here's the question. We have the ellipse given in its general form. We have the line L1, which is the normal to the ellipse, and it has parametric equations, x equals a cos t and y equals b sin t. And the equation of a normal is given. Now, typically in exam questions, you'll have to show this, but for the sake of this example, I'm giving it to you. And the normal, L1, cuts the x-axis at n and the y-axis at n, and we've been asked to show that this is the locus of the midpoint of MN. So this is the locus of the orange ellipse, which is here, okay? So like we did in our previous example, we're told that M lies along the x-axis, so we know that at M, y will equal 0. So we'll substitute 0 into here, and then negative by cos t becomes 0. So we have ax sin t will equal a squared minus b squared sin t cos t. We can make x the subject by dividing both sides by a sin t, and then this one will cancel with this one. So x will equal a squared minus b squared multiplied by cos t over a. And at n, we know x equals 0. And if x equals 0, then ax sine t becomes 0. So we're left with, I'll just block this off, so minus by cos t will equal a squared minus b squared sine t cos t. We'll make y the subject, so we'll divide both sides by negative b cos t. This one will cancel with this one. So we get y will equal negative a squared minus b squared sine t over b. If we go back to our diagram, so we've got the general x coordinate for n and the general y coordinate for n. So now we need to find the midpoint, which is the red dot p. And we can find this midpoint by having the x value at n and the y value at n. So our midpoint then will be a squared minus b squared over 2a cos t. And the y value will be negative a squared minus b squared sine t over 2b. So what we've done with halfness and with halfness. So now we need a way of connecting cos and sine. And we can use the trigonometric identity, cos squared t plus sine squared t will equal 1. So we have our plus, which is here. We have our 1 here. So now all we need to do is make cos the subject of our x value and sine t the subject of our y value. So x is equal to a squared minus b squared over 2a times cos t. So therefore, cos t will equal, we can move the 2a to the right hand side and then divide both by a squared minus b squared. So this will give us 2ax over a squared minus b squared. I'm just going to move this up to leave some space. And then the y we know is given here. So negative a squared minus b squared over 2b sine t. We'll make sine t the subject by multiplying both by 2b and dividing by negative a squared minus b squared. So sine t will equal negative 2by over a squared minus b squared. And now we can square this and substitute it into here. We can do the same for this and substitute that into here. So cos t squared will equal 4a squared x squared over a squared minus b squared all squared. So sine squared t will be, this negative 2 will become positive 4. So 4b squared y squared over a squared minus b squared all squared. And then we can substitute this cos squared into here and this sine squared into here. So finally, we get 4a squared x squared over a squared minus b squared all squared plus the sine squared 4b squared y squared over a squared minus b squared all squared, and that will equal 1. So this will be the equation of the locus of a midpoint of MN. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.